Sweetie, it's time to get up and get ready for school.
Mom, where is everything? There's no strawberries, kiwi fruit, blueberries, orange juice, or pizza.
We don't have any food because the bees are gone. We don't have anything to pollinate the plants.
C. If you thought of maths, chances are you wouldn't associate them with bees. However, bees are sufficiently involved in mathematics. For one, their honeycomb structure uses the most efficient shape, the hexagon. For another, their generations line up with the Fibonacci sequence, like many other natural phenomena. This occurs because male drone bees hatch out of unfertilized eggs and have only one parent. Of bigger importance to our environment, bees are vital pollinators, allowing for crops to grow and helping to produce the food we eat. A case study on honeybees and almond plants by Kimula E. Young helps to show this relationship mathematically. Honeybees pollinate over 75% of crops globally, and this case studies their movements in an almond plantation, considering variables like plant attractors and the maximum density of bee species. It is a system of equations that model the population dynamics of two interacting species. For the success of bee pollination, you need the bees to reach as many different plants as possible. In common orchards, the square, hedgerow, quincunx, and hexagonal patterns, trees of the same variety are in the same row. There are disadvantages in these arrangements, however. The square, though very easy to plant and harvest, creates crowding between adjacent trees. The hedgerow is crowding within rows, so bees fly down the hedge rather than across, reaching plants of the same variety instead of different ones. The quincunx is organised in a square with a tree planted in the middle, and the rows are diagonal, making the distance between trees of the same variety further than that between rows of different trees. Even though this pattern allows for bee pollination, this shorter distance causes problems during harvesting because equipment must travel through the diagonal rows so nuts from different varieties do not mix. The hexagonal pattern has the advantage of reduced canopy crowding and the disadvantage of being harder for activities such as mowing, harvesting, spraying. It has been shown that honeybees will disperse when another insect, like a solitary bee, gets in the area, and Young tries to use this to aid the farmers by causing the bees to disperse and pollinate more plants than crowding around the same trees. A model that Young created which shows the interaction between solitary bees and honeybees is shown as a set of equations. This model is known as the SKT model, and basically it is a model in a set space and time. U1 is the honeybee and U2 is a solitary bee that disrupts the flow. The equation involves both the initial conditions of the bees and the movement condition. J1 is the population flux of the bee species. After computing all of these equations, you get a graph showing the distribution of bees around the trees when they are alone and when another insect disrupted them. In a time where pesticides, pathogens, climate change, and habitat destruction are reducing the amount of bees in the world, we need to maximize their pollinating ability. In the US, 90% of bee colonies for crops that need pollination have disappeared since 1962. And the above analysis on how we can use the natural interaction of species to do so will save a lot of effort. And that's just bees. If you pick anything in our world, you can relate it to mathematics in some way. Maths in medicine, technology, figuring out weather patterns, construction. Maths makes everything possible, and that's why we choose maths.
So if we listen to maths, we'd have all of my favourite foods.
Yes, math makes everything possible, including breakfast.